Hello, everybody. Welcome to our science lesson number 3. Before I begin, pause the screen and make sure you have a pen, a pencil, and something to write on. Right, let's begin. So, we're going to research melting and boiling points. Before we start, we're going to begin with our knowing more, remembering more. So, the first question is a thermometer is used to measure temperatures. A thermometer is used to measure temperatures. True or false? The next one, which of these solids can turn into liquids? Is it plastic, metal, ice, or glass? Which of these solids can turn into liquids? Is it plastic, metal, ice, or glass? There's more than one answer for this one. The next one, what state of matter is a piece of wood? What state of matter is a piece of wood? Is it a solid, a liquid, or a gas? Final question, what piece of equipment is used to turn off an electrical circuit? What piece of equipment is used to turn off an electrical circuit? You can now pause the screen and go through your answers. Okay, let's see how we did. So the first question was a thermometer is used to measure temperatures. The answer is true. We do use a thermometer to measure temperatures. The next question, which of these solids can turn into liquids? It is in fact all of them. Plastic, metal, ice and glass can all be turned into liquids as long as they are heated above their melting point. What state of matter is a piece of wood? And the answer is a solid. And the final question, what piece of equipment is used to turn off an electrical circuit? And the answer is right here, it's a switch. I hope you did well. Now, your success criteria for today, what temperature do substances change state are, I can define melting, freezing, and boiling. The second one, I can draw a bar graph of different melting points. And the third one, I can interpret the data from my graph. Your keywords are my turn, your turn, boiling point, melting point, and freezing point. Well done for repeating after me. So let's just recap the states of matter. So you have some images on the screen. What state of matter is each of the following objects currently in? You have a block of wood, it looks like a tree stump. You have a block of ice, some water with a water droplet there, some steam coming from a pot, milk, and some fruit. So I'll pause the screen and go through which state of matter each of the following objects is currently in. Okay, let's go through the answers. So the first one is the wood, it's a solid. The ice is solid. The water is liquid. The steam coming from the pot is gas. The milk is a liquid and the fruit is both solid and liquid. How did you do? Right. Can substances change their state? Can a substance sometimes be a solid, but other times be a liquid? What do you think? Yes, of course. When we can witness metal as a solid and a liquid. Can you think of any examples? We say that substance has changed states. I am now going to show you a video of a substance which is metal, which is a liquid and will be cooled down to become a solid. So as you could see from the video, you had the metal which was heated to become a liquid, and it was being poured down the tube, and then after it came out of the tube, it was being cooled down by water to become again solid. So let's have a look at changes of state. There are the 4 main changes of state. Can you name any of them? Pause the screen. Okay, let's see how you did. We had melt, boil, condense, and freeze. Those are the 4 main changes of state: melt, boil, condense, and freeze. So what happens during melting? During melting, a solid turns into a liquid. Can you give another example other than ice melting? Pause the screen. Let's see how you did. We have chocolate, cheese, and rubber. Did you think of any that are not here? Well done. Freezing. What happens during freezing? Well, during freezing, a liquid turns into a solid. So you have water, which is a liquid, which turns into ice when it is frozen. Can you think of any other examples other than water freezing? Pause the screen. Let's see how you did. We have chocolate and snowflakes. So think about what snowflakes are before they become snowflakes. Did you think of any that aren't here? Well done if you did. Melting and freezing. What I want you to do is have a look at this video and then answer the questions after the video. So the questions that you will be required to answer are: how are melting and freezing linked? What is the melting point of water? And what is the freezing point of water? So we're going to have a look at the video, then answer the questions.
Hey there, looking sharp? You're going to show us how to change the state of a substance by heating or cooling it with the aid of these temperature-controlled rooms. When solids are heated, they can melt into liquids. And when we freeze a liquid, it becomes a solid. Hadn't you better check on them? Right, after being heated, the ice has melted into water. For water, this melting point is 0 degrees Celsius. And it looks like you've done a fair bit of melting yourself. When we freeze water, it becomes ice. It's changed from a liquid into a solid. This happens when the temperature drops below 0 degrees Celsius. Someone here's become a bit icy too. But of course, freezing and melting are totally reversible processes. So, who wants another go?
So let's see if we can answer the questions. How are melting and freezing linked? Pause the screen. Let's see if you were correct. They are opposites of each other. Next question. What is the melting point of water? Pause the screen. Let's see if you were correct. 0 degrees Celsius. And the last question on this slide. What is the freezing point of water? Pause the screen. And it's just below 0 degrees Celsius. So well done if you got those all correct. So boiling, what happens during boiling? During boiling, a liquid turns into a gas. It's more difficult to give examples of boiling than it is for melting because it happens at higher temperatures for a lot of substances. Can you remember what the 4th change of state was called? Pause the screen. Okay, let's see if you are correct. It was condensation. We will look at this next lesson. So we have definitions for melting, freezing, and boiling. I would need you to write these in your books once I've gone through them. So melting is when a solid turns into a liquid. Freezing is when a liquid turns into a solid. And boiling is when a liquid turns into a gas. So pause the screen and write these into your books, please. So let's have another look at our success criteria for today. The first one was I can define melting, freezing, and boiling. We've just done that, so you can give yourself a tick. Well done. The next success criteria we're going to meet is I can draw a bar graph of different melting points. So displaying our data, We know that different materials have different melting, freezing, and boiling points. Which has a higher melting point, water or metal? Pause the screen. The answer is metal. We have to heat it to a higher temperature to make it melt. We can display this information in a graph to make it easier to understand. So collecting our data, you each have a table of melting and boiling points of different metals. Your table has some information provided and some information missing. Fill in the missing information on your table by doing some research. Remember to ask scientific questions such as, what is the melting point of copper? Displaying our data. When you have all the information, create a bar chart showing the melting point of the different materials on the axis provided. Looking at the title of the bar chart, are we using the melting point or boiling point data from our table? Well done if you thought about it and you said the melting points. Think about the spacing of the numbers on your axis. How are we going to draw the first bar for aluminium? So you need to look at your information that you have collected, and you need to look at the melting point for aluminium, and we know that it is 700. Therefore, you would draw your bar up to 700 just in the aluminium column, and you can color that in. So once you've completed your graph, this is what it should look like. If it doesn't, you can think about what you may have done incorrectly for it not to look like the one in front of you. So we have now completed our second success criteria, which is I can draw a graph of different melting points. So here's some questions about your graph. And what I'd like you to do is pause the screen after each question so you can answer it in full sentences in your book. Using your graph, answer the following questions. The first question, which metal has the highest melting point? What is it? Write the answer in your book. Which metal has the lowest melting point? What is it? Write the answer in your book. Which metal do you think is liquid at room temperature? Write the answer in your book. And which metals have a melting point that is higher than water? You can write the answer in your book too. So let's go through the answers. For the first question, which metal has the highest melting point? The answer was iron at 1500 degrees Celsius. The second question, which metal has the lowest melting point, was in fact mercury, which has a melting point of minus 100 degrees Celsius. Which metal do you think is liquid at room temperature? And we had mercury because it melts into a liquid at minus 100 degrees Celsius. Which metals have a melting point that is higher than water? And the answer is aluminium, copper, gold, iron, and lead. All metals apart from mercury. So let's see if you can extend your learning now. Write a question for your partner or somebody at home to solve about the information in your bar chart. Let's look at this data and answer the question. So which materials would be liquids at room temperature? Okay, which metals would be liquids at room temperature? That means they should have a low melting point. So have a look at your graph. Which metals have a low melting point? And the answer is mercury, olive oil, and ice. The next question, the average winter temperature in the Arctic is about minus 30 degrees Celsius. Which material would still be a liquid in an Arctic weather? Which material would still be a liquid in an Arctic weather? And the answer is mercury. Well done if you got that correct. So finally, we can tick our last success criteria for today, which is I can interpret the data from my graph. Well done. So let's finally review your knowledge with some true or false questions. So I'll read them out to you. Melting is when a solid turns into a liquid. True or false? Melting is when a solid turns into a liquid. It's true. So you can pause after I've asked the question so that you can answer it. Second question, water turns into ice when heated. Water turns into ice when heated. Is that true or false? Pause the screen. Okay, it's false. When water boils, it turns into air. When water boils, it turns into air. Is that true or false? Pause the screen. It is, in fact, false. When water boils, it turns into steam, doesn't it? Freezing is the opposite to melting. True or false? Freezing is the opposite to melting. Pause the screen. It is, in fact, true. Last question. The 4 changes of states are melting, freezing, boiling, and condensing. The 4 changes of state are melting, freezing, boiling, and condensing. True or false? Pause the screen. Let's see. You are right. It is true. And we are going to stop there. That is the end of the lesson. So well done for joining me. Well done for downloading the video. And I'll see you next week for your 4th science lesson. Bye.